is Anjali Nigam, and I'm an assistant professor in the engineering department. In the last session, we talked about some basic terminologies used in graph theory. First, we discussed the definition of graph, that how it is used to represent objects and the relationship between them using vertices and edges. And then we talked about its different types, its different kinds, such as simple graph. A simple graph doesn't contain any loops. And then we talked about multigraph, that how it may contain more than one edge between two vertices. Then we talked about directed graph, that how a direction is assigned to the edges between two vertices. And then in the last, we talked about labeled graph, that how each and every vertex was distinctly defined. In today's session, we'll talk about graph and its examples, how this subject helps to solve our real life complex problems. So let's get on with the presentation. So graphs and examples. The learning objective states that at the end of this session, you will be able to understand graphs and its examples. We'll focus with the help of examples that how graph theory helps us to solve our problems. So what kind of problems graph theory helps us to solve? Graph theory deals with problems which have a fairly natural graph or network structure. So it deals with problems that have a fairly natural graph. That is, the problem can be divided into vertices and edges, then only we can solve it. Problems such as road networks or communication networks, when we are able to divide the problem in the vertices and edges and we are able to show the flow of communication between them, then only graph theory helps us to solve those particular problems. As you can see in the image that has been provided for you, how some users are sending or receiving emails. The vertices are representing users and the edges are representing whether the email has been sent or whether it has been received. Now let's see another example to make it even more clear. It's an example of a computer network. In the example, you can see that there are certain cities like San Francisco, Los Angeles, Denver, Chicago, Detroit, New York, and Washington. The vertices are representing some cities and the edges are representing communication networks. The vertices of graph represent data centers in a given city. So these vertices are representing data centers in these particular cities. And the edges represent the communication link between them, that how San Francisco is connected to Denver and how Denver is connected to Chicago, how Chicago is connected to Detroit, New York, and Washington. So such problems which have a fairly natural graph structure, it can be divided into a fairly natural graph structure. Such problems can be easily solved by graph theory. Now let's consider an oil field example. There's a problem given to you that we have 4 wells in an offshore oil field, that is nodes 1 to 4, and an onshore terminal node 5. So in the image, you can see that there are 5 vertices. The first 4, that is 1, 2, 3, 4, they represent an offshore oil field, and node number 5 represents an onshore terminal. The 4 wells in this field must be connected together via a pipeline network to the onshore terminal. So what we have to do in this particular problem, we have to connect the 4 wells via a pipeline to the onshore terminal. That is, we have to connect node 1, 2, 3, and 4 to node 5. The edges would represent a pipeline. So let's see how they have done that. As you can see in the image, node 1 is connected to node 2, node 1 is also connected to 3, 1 is connected to 4, and 1 is also connected to node 5. So they have connected the vertex 1 to all the other nodes. They have done the same thing with node 2, node 3, node 4, and node 5. They have connected all the vertices with each other. Now, you may see that there are certain numbers which you can see on the edges. Like the edge between node 1 and node 2 contains the number 3. The edge between node 2 to node 3 contains the number 6. So what are these numbers exactly? The various pipelines that can be constructed are shown as links in the diagram, and the cost of each pipeline is given next to the each link. So what these numbers represent? These numbers represent the cost. That is, what would be the cost of the pipeline if we construct it between node 1 and node 2? The cost would be 3. So why are these costs needed? Obviously, when you construct something and as a developer, you want the cost to be as low as possible. So these costs are given so that in the end, you can calculate that which would be the best optimal solution for you. So graph theory not only helps us to solve some problems which have a fairly natural network structure, it also helps us to find out the cost. So the summary states that in this session, we have discussed graphs and its examples. I hope the examples of data center and oil field was clear to you. And I hope you noticed that how graph theory helps us to solve some problems which have a fair network structure, problems which can be divided into vertices and edges. So we studied about graph and its examples in today's session. And in the next session, we'll be studying about network and weighted graph. We'll find out how network and weighted graphs are different from the graphs we have studied earlier and how they help us to solve our problems. I hope you enjoyed today's session. My name is Anjali Nigam, and thank you for joining me.